Okay, so a gap in my knowledge has been exposed around Clojure's for function. So I've asked ChatGPT to give me some practice problems. So the first one, it suggested basic sequence generation. Create a sequence for the first 10 square numbers. Cool. So let's just make a let's just copy my template project. Start the REPL. Cool. Right, so first 10 square numbers. So first 10, is that what it said? So there's two parts to this problem. So first 10 square numbers. Is 4 even? I feel like this would be a good fit for a lazy generator. I don't know if 4 is lazy, but anyway. Alright, so first 10 square numbers. First 10, does that fit with how 4 works? Because the way I understand 4, it takes some input variables which are predefined. The problem is, right, so what we're going to have to do is we're going to have to start with 1. And we're going to have to go, we're just going to have to walk upward through the numbers and test if each one is a square number, right? So if we do a square root on it, and the result, is that right, or is there a different way of doing it? Oh, hang on. No, we can do it the other way, can we? Yeah, we can we? So we can just start. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4, oh, yeah, so, okay, it's easier than I thought. Cool, so first 10, right? So I think the first thing we do in these brackets is we define our bindings, right? So we want to go range from 1 to well, no, because we don't need to implement this as a function. We're just GPT Engineer hasn't given us a batch of tests or anything. It's just cool. So right, let's just check that this does what we think. So what happens if we just do I? So what does this do? Cool. So all we need to do is oops, so that's not wrong programming language times cool. So can I Do I get a reward? Here's a breakdown of your code. Yes, I know how it works. I just wrote it myself. Okay, anyway, so the second problem is nested loops generate a Cartesian product of two vectors. So the Cartesian product, so it shouldn't, so we don't care about order, right? So we don't need 1 and 4 and 4 and 1 because they're considered equivalent, right? So no duplication with different ordering. Yeah. Yeah, so I think Cartesian product is exactly yeah, so this is exactly the kind of thing I don't know how to do. Because what happens if we do oh, we might have done it. Is that really it? No, that's it. So it just gives you all, so I'm guessing if we wanted, that's quite cool. So 4 essentially is automatically calculating the Cartesian product, right? It's just a innate part of its functionality. It just always gives you all combinations of. I mean, how's this explained in the documentation? Ah, it's lazy, that's nice. Okay, cool. Conditional filtering. Generate a list of all even numbers between 1 and 20 inclusive. Yeah, so yeah, this for function seems to be quite the Swiss Army knife. Sorry, all even numbers between 1 to 20. Yeah, so it talks of these modifiers. I see. So it's doing a lot of automatic logic. Inside these square brackets, it's automatically calculating the Cartesian product, and it's applying these modifiers, such as while. So while, how do we check if a number's, well, is there like an even? No? Well, in that case, well, we can check if the mod tells you the remainder of a division. So the question is, if we divide it by 2, so rather than doing equals to 0, is there like a 0? No? Let's just check we're using this right. Truncates towards no, whatever. No, I'm in division. Yeah, that's not right. Right. Does this work then? Wrong number of arguments. Yeah. So that hasn't worked. So okay. So why hasn't that worked? Clearly, I've done it wrong. Okay. So what have I done wrong? Huh. Okay, well, let's look at some examples, right? So Clojure 4. Oh, I wrote while, but it should have been when. What's the difference between while and when? There's a performance difference. Oh, I see. So while is just it's gonna abort, right? It's gonna abort and not go any further. Whereas when is gonna continue looping through everything. So that's why our output is like that. Cool, has that worked? So all even numbers, yeah. Cool. That's it. Cool. Cool, so what did we land? So yeah, this thing's a pretty nice gimmick. Cool, so using let for intermediate calculations. So you create a sequence of the sum of each pair of numbers from 2 vectors. We don't need to use let for that, do we? But yes, we do, because it basically calculates the Cartesian product. So, okay, hang on a second. All right, well, this is interesting. So it wants us to do 1, 2, 3, and 4, 5, 6. So let me show you, so what I was originally thinking, but this won't work. I was originally thinking we can just do, what was it, summing them? Sums. So I was originally thinking we could just do, but that isn't right because it's summing the Cartesian product, but what it wants is for us to sum each pair, like the first item in the first list is summed with the second item in the second list, etc., etc. So what's it saying? So we have to use let. So so how do we use let? This Clojure's 4 thing seems to be like a total Swiss Army knife. So where does it actually explain how to use let? Oh, it's right here. So so we're creating a new, right? So we're creating a new value. So where's the documentation that actually explains this? I was looking in my my Clojure books this morning to see what they say about let, and they don't have much to say about it. So so what's the syntax? So let. So let takes its own. But what's the I haven't seen any explanation for 1 plus 4. No, this isn't right because it's still doing the Cartesian product, right? Yeah, so ChatGPT might have given us an awkward question. Yeah, because what we're doing is not equivalent to that. I mean, it could just be that I'm not doing it right. I mean, so if you want to pair things up, I mean, you would normally use map. So hang on, let me demonstrate how we would do this with map. So we just do map plus is that right? Yeah, that's correct. So yeah, the correct way to solve So is it giving us a more challenging problem? So given two vectors, create a sequence where each element is the product of an element from the first vector and the sum of the corresponding element and its index. Okay, so now things are getting interesting. Right. So what they're doing here is they're creating a bunch of indexes, right? So given two vectors, cool. So what can we learn from this? Yeah, I don't know. I'm going to move on. So problem 5. So combining multiple collections. For two collections, generate a sequence that combines each element from the first collection. Sorry, I'm going to pause for a moment. Right, where were we? Combining, so generate a sequence that combines each element from the first with each element from the second. That's just easy, isn't it? So, it's very similar to yeah, similar to the second one. It's like a Cartesian product, except we're running everything through a function as well. I'm sure this is easy. Don't we just do yeah, A1, A. Yeah, I think that's what it wanted. Yeah, so that was just easy.